Welcome to Physics NP, the first series of physics multiple choice questions equally applicable for all type of entrance examinations. These are the questions from Kinematics. The first question is, a particle is projected vertically upward from A. It takes T1 to reach B and further T2 to reach ground from B. Height of B is A, B, C and D. So consider this as point A. From A, a particle goes to B and from B to ground. And this is the point B. And according to question, from A to B time taken is T1 and from B to ground is time taken T2. So here the total time for the projectile will be T is equal to T1 plus T2, and by formula T is equal to 2U sine 90 because the particle is projected vertically upward, so sine 90 and whose value is 1, so 2U by G. Finally we get U is equal to GT by 2 or G by 2 T1 plus T2. This gives the initial velocity of projection. And now for AB, height AB is from equation of motion ut minus half ut1 minus half gt1 square. Putting the value of u from above, g by 2 t1 plus t2 into t1 minus half gt square. Solving, what we get, the solution is 1 by 2 g t1 square plus 1 by 2 g t1 t2 minus 1 by 2 g t1 square. This and this cancel. Finally we get 1 by 2 g t1 t2. So our correct option is B. Next question. The position of an object is xt. It is definitely moving towards the origin when options A, B, C and D. Okay, so what we will apply here, that square of distance from origin will be equal to x minus 0 square, that is x square. And according to question, moving towards origin. So if the object is moving towards origin, value of x square must decrease with time. So definitely if this value is decreasing with time, then the derivative of x square must be less than 0. So option is C. Now third question. A particle moves with velocity v is equal to t square minus t. The time interval for which the particle retards is A, B, C and D. So first we have velocity v is equal to t square minus t, and acceleration is derivative of velocity, that is 2t minus 1. Now for retardation, what we must know, that v must be v and acceleration should be opposite. That means if b is positive, acceleration must be negative to say it as retardation. So in that case, the product of B and A will be less than 0. Putting the value from above, t square minus t and 2t minus 1 less than 0. T common, t minus 1, 2t minus 1 less than 0. So we will check the interval. So this inequality is satisfied only in the interval B. Hence the correct option is B. Now moving to the fourth question. A ball is dropped from a height of 80 meter. What is its velocity just before hitting the ground? The options are A, B, C and D. This is a very simple question, and the hint is also given. When an object is dropped from a height to the ground, obviously the first velocity is 0 and we need to calculate the last velocity. We know formula b square is equal to u square plus 2gh 0 plus 2 into 10 into, and height is given as 80. This is 80 1600 b square, therefore b is root under 1600. This is 40 meter per second. Our correct option is C. Now moving to the fifth question. The area under a velocity time graph represents which physical quantity? Acceleration, force, displacement, impulse. But then area under the velocity time graph is given by integration. Area is given by integration. The graph is of velocity in respect of time, so the area will be v dt. So you can see velocity into time. Velocity into time is displacement. Displacement. So our correct option is C. Now question number 6. A car starts from rest and accelerates uniformly 2 meter per second square velocity after 5 seconds. It's a simple question. What we apply here, b is equal to u plus 80 0 plus 2 into 5 10 meter per second. Question number 7. The escape velocity for Earth is 11 km per hour. If a satellite is launched at 45 degree with the horizontal, the escape velocity will be. So here the concept is escape velocity. Escape velocity for Earth is given by formula 2g m by r. G is universal gravitational constant, m is mass of the Earth, r is radius of the Earth. So you can see the formula is independent to angle of projection. So whatever angle we project the object or satellite, the escape velocity will be same. So the answer is 11 km per second. Now question number 8. A projectile is fired with velocity u at angle theta if its speed when its direction makes angle alpha with the horizontal is. The options are A, B, C and D. So there is something correction in the figure, velocity u. So when the object is thrown with velocity u, first the angle of projection is theta, and later on the angle of projection will be alpha. Now what will be the velocity over here? No need values. velocity over air if when the angle of projection will be alpha. So here the concept is used as that the horizontal velocity remains constant during the motion. That is, at the initial point, horizontal velocity is u cos theta, and since at point this the velocity is v and angle of projection is alpha, the horizontal component will be v cos alpha. And by the concept of projectile motion, both of these quantities must be same, because we know that in projectile there is no any force in the horizontal direction, so the horizontal component at all point will be same. Now this is given by u cos theta into 1 by cos alpha equal to v, and finally v is equal to u cos theta into sec alpha. So our correct answer is A. Next, question number 9. A car moving with velocity b is stopped in distance x. If the kinetic energy is doubled, the stopping distance will be A, B, C and D. Now what we can use the concept over here is kinetic energy is equal to half mv square, or 1 by 2 m 2a x distance. We have used the formula b square is equal to u square plus 2as. This is 0 and distance is x in the question. Now when the kinetic energy is doubled, so 2 times kinetic energy, that means 2 times 1 by 2 m 2ax 1 by 2 m 2a into 2x, this 2. So comparing this and this, what we get, the distance is doubled. Question number 10. If a body covers equal distances in equal interval of time, then its acceleration is. So equal distance in equal interval of time, both are equal by equal, that is a constant. That means it is a constant velocity, so acceleration is 0. Now question number 11. The relation between linear velocity and angular velocity is v is equal to omega. This is the relation between v and omega. Answer is B. Question number 12. Average speed. A vehicle moves at 60 km per hour for 30 minutes and 40 km per hour for next 30 minutes. If its average speed is, we need to calculate the average speed. So here how we calculate the average speed? We first calculate the distances in both the cases. 60 into 0.5 hour, and similarly 40 km per hour into 0.5 hour, both gives 30 km and 20 km. Total distance 50 km, total time 1 hour. So average speed will be total distance by total time 50. So in this case we have calculated different distances first, but if you know that in both the cases there are same time, then we can calculate directly average speed as b1 plus b2 by 2, that is 60 plus 40 by 2 is equal to 50. The answer is 50. Question number 13. A body starts from rest with acceleration 2 meter per second square. The average velocity between t equal to 1 second and t equal to 5 second is. So we need to calculate time. Average velocity between t is equal to 1 second and t is equal to 5 second. Now what we concept apply here, that u is equal to 0 and a is 2 meter per second square. At t is equal to 1, its velocity will be u plus at, that is 0 plus 2 into 1, 2 meter per second. Similarly, at time t is equal to 5 second, its velocity will be u plus at, 0 plus 2 into 5, that is 10 meter per second. And now we need to calculate the average speed. So average speed is v1 plus v2 by 2, that is 2 plus 10 by 2, 6. The answer is 6 meter per second. Next, question number 14. The slope of a displacement time graph represents. So graph of time and displacement, for example this, and when we calculate the slope, this gives the slope. The slope is ds and dt, that is slope is distance by time, this is velocity. Question number 15. A projectile is at the same time at t is equal to 3 seconds and t is equal to, a projectile is at the same height at t is equal to 3 seconds and 5 seconds. The total time of flight is A, B, C and D. So in case of projectile motion, you can see in projectile motion, if this is the point at the same height and this one is time is 3 seconds and this one time is 5 seconds, then in projectile the motion is very symmetrical, so this must be 3. In that case, all total time will be equal to 5 plus 3, that is 8 seconds. Question number 16. A man walks up a stalled escalator in 90s. The moving escalator carries him in 60 seconds. Time taken to walk up the moving escalator is A, B, C and so escalator, let this be the escalator, moving escalator, something like just like in Bhatbateni in supermarket. Let its length be L. So when this escalator was not working, in that time the man takes 90 seconds to cross up. That means the speed of the man will be equal to total length by time 90 seconds. And when the escalator walks itself upward, run upward itself, in that case it takes 60 seconds to reach upward. That means velocity of the escalator will be length by 60. When both the person and the escalator both are working, that means man is also walking upward, and the machine is also going upward. In that case, the resultant velocity will be the sum of man and escalator, that is L by 90 plus L by 60. Taking LCM and solving, this gives 5L by 180, this is L by 36. So time is 36 seconds. Question number 17. Which of the following is the vector quantity? Very simple question. Velocity is the vector quantity. Question number 18. A body is projected horizontally from a tower with 5 meters per second. This is a tower, and a body is projected horizontally with 5 meters per second. Its speed after 0.3 second is, just consider that the projectile reaches at this point at 0.3 second. So what will be the velocity at this point? Very simple, we have direct formula to calculate the velocity. V is equal to u square plus gt whole square, that is 5 square plus 10 into 0.3 square equal to 25 plus 9, this is equal to root under 34. That means the correct answer is C. Now next question. Question number 19. A particle projected horizontally from a 20-meter tower has a horizontal acceleration of 6 meters per second. Acceleration in horizontal direction is 6 meters per second. The tower is 20 meters. Its horizontal displacement is. So what we need to, after falling downward, how much away this will fall downward, we need to calculate that. But the thing is a little bit different. We have here horizontal acceleration 6 meters per second square. So first let us calculate how much time does it take to reach the ground. So for that, h is equal to half gt square, 20 is equal to 5t square, t is 2 seconds. So the projectile will come downward in 2 seconds, and in 2 seconds it will cover the distance, horizontal distance. S is equal to ut plus half at square, that is u. You need to so if you consider u as 0, then we get 1 by 2 acceleration into 6 times 2 square, 6 to the 12 meter. Answer is A. Next. A displacement time graph is a straight line making 45 degree with the time axis. This indicates, so this is displacement time graph, which is a straight line making angle 45 degree. So we know that the slope of the graph is tan 45, whose value is 1, and slope determines velocity is 1 meter per second, that means constant velocity. Question number 21. A projectile is fired at an angle theta at maximum height, the velocity and acceleration are. So when the projectile is fired at angle theta at the maximum height, at this point there is only horizontal velocity, and the acceleration is vertical. So they are perpendicular to each other. Question number 22. The motion of a freely falling body is an example of body freely falling downward. In that case, V increases. Acceleration is constant, that is equal to G. So what we can say it as uniform acceleration. A ball is tossed vertically towards with 20 meters per second. A ball is tossed vertically upward with 20 meters per second. How long does it take to reach maximum height? So ball is tossed upward. We need to calculate the maximum height, and the initial velocity is 20 meters per second. And how long does it take to reach over here? So very simple, the final velocity is v is equal to 0. So what v is equal to u minus gt. 0 is equal to 20 minus 10 into t. T is equal to 2 seconds. Our answer is 2 seconds. Question number 24. If position x is equal to 4 minus 9t and y is equal to t square, find the speed at t equal to 2 seconds. Question number 24. The 4 options are given on the screen. Now first we calculate bx as dx by dt, that is minus 9. Similarly, by is equal to dy by dt, that is 2t, and velocity will be equal to bx square plus by square, that is 9 square plus 4t square, and at t is equal to 2 seconds, v will be equal to 9 square plus 4 into 4, that is 81 plus 4 is 16, that is root under 97 units per second. Question number 25. A boat can move at 8 km per hour in still water. How long will it take to move 24 km downstream if the river speed is 4 km? So velocity of the boat 8 km per hour, velocity of the river 4 km per hour. In case of downstream, both are in the same direction, so the resultant velocity will be velocity of boat plus velocity of river, that means 8 plus 4 equal to 12 km per hour, and distance is 24 km. So time is d by v, that is 24 by 12, that is 2 hours is our answer. Question number 26. The velocity of a projectile is v is equal to 3t plus 2. V is equal to 3t plus 2. Its acceleration. So acceleration is dv by dt, that is d by dt, 3t plus 2, this gives 3 meter per second square. Since there is no time, so we don't need to calculate for 2 seconds. The acceleration is constant, 3 meter per second square. Next question. An object moves at constant speed of 6 meter per second. This implies constant speed of 6 meter per second moves. This implies A moves 6 meter every second. B acceleration is 6 meter per second square. Velocity is always positive. It is at rest. and better this one, moves 6 meter every second. So option is A. Question number 28. In a perfectly inelastic collision, the relative velocity after collision. So for perfectly inelastic collision, the relative velocity of the two colliding body is, so in the definition of inelastic collision, the two bodies collide to stick together. That means both move with the same velocity. So relative velocity will be 0. Question number 29. A particle starts from x is equal to minus 15 meter. Its velocity is 10 meter per second. Position after 2 seconds. So in this case, what we can say that the position for a time is given by x naught plus v into t. Minus 15 plus 10 into 2. Minus 15 plus 20, that is 5 meter. Is the correct answer. Question number 30. Magnitude of centripetal acceleration for a body. So, centripetal acceleration is b square by r. Answer is B. So we have completed 30 important physics MCQ questions for entrance.